Galvanic corrosion is a legitimate concern in electrical installations, particularly when dissimilar metals come into contact in the presence of moisture. In the scenario of using steel staples to secure aluminum metal clad cable, or MC cable, the risk of galvanic corrosion is present. Aluminum and steel are dissimilar metals, and moisture is a common factor in many electrical environments. When these three elements are combined, galvanic corrosion can occur, potentially leading to the deterioration of the aluminum MC cable. The underlying principle of galvanic corrosion involves the electrochemical process that occurs when two dissimilar metals are immersed in an electrolyte, such as moisture. One metal acts as the anode, corroding at an accelerated rate, while the other acts as the cathode. The difference in electrical potential between the metals drives the corrosion process. In the case of steel staples and aluminum MC cable, the aluminum tends to act as the anode, meaning it corrodes preferentially compared to the steel. This corrosion can weaken the aluminum cable, potentially leading to electrical failures or safety hazards. The electrical inspector is correct in pointing out this concern and requiring the removal of the steel staples. Replacing them with compatible alternatives is crucial for ensuring the long-term reliability and safety of the electrical installation. Acceptable alternatives include aluminum staples, which are metallurgically compatible with the aluminum MC cable, or plastic staples, which eliminate the risk of galvanic corrosion altogether by providing an insulating barrier between the metals. There are several factors that influence the rate and severity of galvanic corrosion. Firstly, the difference in electrical potential between the two metals. The greater the difference, the faster the corrosion rate. Secondly, the presence of an electrolyte, such as moisture, is essential for the corrosion process to occur. The electrolyte provides a medium for the flow of ions, which is necessary for the electrochemical reactions. Thirdly, temperature can also affect the rate of galvanic corrosion. Higher temperatures generally accelerate the corrosion process. Fourthly, the surface area ratio between the anode and cathode can also play a role. If the anode has a smaller surface area than the cathode, the corrosion rate at the anode will be higher. In the context of electrical installations, moisture can come from various sources, including condensation, humidity, leaks, or direct contact with water. Therefore, it is essential to consider the potential for moisture exposure when selecting materials and installation methods. To mitigate the risk of galvanic corrosion, there are several best practices that should be followed. Firstly, select compatible materials whenever possible. Use metals that are close together in the galvanic series, which is a ranking of metals based on their electrochemical potential. Secondly, avoid using dissimilar metals in direct contact with each other. If dissimilar metals must be used, provide an insulating barrier between them, such as a non-conductive coating or tape. Thirdly, apply protective coatings to the metals to prevent them from coming into contact with moisture. Fourthly, design the system to minimize moisture exposure. Provide proper drainage and ventilation to prevent water from accumulating. Fifthly, use sacrificial anodes. A sacrificial anode is a metal that is more readily corroded than the other metals in the system. The sacrificial anode corrodes preferentially, protecting the other metals from corrosion. Sixthly, regularly inspect the installation for signs of corrosion. Look for discoloration, pitting, or other signs of deterioration. Address any corrosion problems promptly to prevent them from escalating. When selecting staples for securing electrical cables, it is important to consider the material compatibility between the staple and the cable. Aluminum staples are a good choice for aluminum MC cable because they are made of the same metal. Plastic staples are also a good option because they provide an insulating barrier between the staple and the cable. Steel staples should be avoided when securing aluminum MC cable because they can lead to galvanic corrosion. In addition to selecting compatible materials, it is also important to install the staples properly. The staples should be securely fastened to the support structure, but they should not be over-tightened. Over-tightening the staples can damage the cable or create stress points that can lead to corrosion. It is also important to ensure that the staples are not installed in areas where they will be exposed to excessive moisture. In wet or damp locations, use waterproof staples or provide additional protection against moisture. The National Electrical Code, or NEC, provides guidance on the proper installation of electrical cables and equipment. While the NEC does not explicitly prohibit the use of steel staples with aluminum MC cable, it does contain provisions that address the issue of corrosion. For example, NEC Section 300.6 requires that electrical equipment be protected against corrosion. This section states that metal raceways, cable armor, boxes, cable supports, and fittings shall be of materials suitable for the environment in which they are installed. This requirement can be interpreted to mean that steel staples should not be used with aluminum MC cable in locations where corrosion is likely to occur. In addition to the NEC, there may be local codes or regulations that specifically address the issue of galvanic corrosion. It is important to check with a local electrical inspector to determine the applicable requirements. In summary, galvanic corrosion is a potential concern when using steel staples to secure aluminum MC cable. To mitigate this risk, use compatible materials, avoid direct contact between dissimilar metals, apply protective coatings, minimize moisture exposure, and regularly inspect the installation for signs of corrosion. The electrical inspector is correct in requiring the removal of the steel staples and replacing them with a suitable alternative, such as aluminum or plastic staples. By following these best practices, you can ensure the long-term reliability and safety of your electrical installations. Aluminum MC cable is a common type of electrical cable used in residential, commercial, and industrial buildings. It consists of insulated conductors enclosed in a flexible aluminum sheath. The aluminum sheath provides mechanical protection for the conductors and also serves as a grounding path. Aluminum MC cable is lightweight, easy to install, and resistant to corrosion. It is a popular choice for many electrical applications. However, as discussed earlier, it is important to be aware of the potential for galvanic corrosion when using aluminum MC cable with steel staples. When installing aluminum MC cable, it is important to follow the manufacturer's instructions and all applicable codes and regulations. The cable should be properly supported and secured to prevent it from sagging or becoming damaged. The connectors used to terminate the cable should be compatible with aluminum and should be properly tightened to ensure a good electrical connection. The grounding path should be continuous and reliable. In addition to galvanic corrosion, there are other potential hazards associated with electrical installations. These hazards include electrical shock, fire, and arc flash. It is important to take precautions to protect yourself from these hazards when working with electricity. Always to energize the circuit before working on it. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. Proper grounding is essential for electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. The grounding system should be properly installed and maintained to ensure its effectiveness. The NEC contains detailed requirements for grounding electrical systems. These requirements cover the size and type of grounding conductors, and methods of connecting grounding conductors, and the location of grounding electrodes. It is important to follow these requirements carefully to ensure that the grounding system is safe and effective. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. It is important to stay up to date on the latest codes and standards to ensure that your electrical installations are safe and compliant. The NEC is updated every 3 years. Other organizations, such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA, also publish electrical standards. Continuing education is a good way to stay informed about changes in electrical codes and standards. Many organizations offer training courses and seminars on electrical safety and code compliance. By investing in continuing education, you can improve your knowledge and skills and ensure that your electrical work is safe and compliant. In addition to the specific issue of galvanic corrosion with aluminum MC cable and steel staples, it is important to have a general understanding of corrosion principles in electrical systems. Corrosion is the deterioration of a material due to chemical reactions with its environment. It can occur in a variety of forms, including uniform corrosion, pitting corrosion, crevice corrosion, and galvanic corrosion. Understanding the different types of corrosion can help you to identify potential problems and take steps to prevent them. Uniform corrosion is a type of corrosion that occurs evenly over the entire surface of a material. It is often caused by exposure to a corrosive environment, such as acid rain or salt water. Pitting corrosion is a type of corrosion that occurs in small localized areas. It is often caused by the presence of chloride ions or other contaminants. Crevice corrosion is a type of corrosion that occurs in narrow spaces, such as under washers or gaskets. It is often caused by the accumulation of moisture and contaminants in the crevice. Galvanic corrosion, as discussed earlier, is a type of corrosion that occurs when two dissimilar metals are in contact with each other in the presence of moisture. To prevent corrosion in electrical systems, it is important to select materials that are resistant to corrosion, protect the materials from exposure to corrosive environments, and regularly inspect the system for signs of corrosion. Corrosion can lead to electrical failures, safety hazards, and costly repairs. By taking steps to prevent corrosion, you can ensure the long-term reliability and safety of your electrical installations. Also, electrical inspections are an important part of ensuring electrical safety. Electrical inspectors are trained to identify potential hazards and code violations. They can help you to ensure that your electrical installations are safe and compliant. Electrical inspections are typically required for new construction, renovations, and repairs. The frequency of electrical inspections may vary depending on the location and the type of installation. It is important to cooperate with the electrical inspector and address any concerns that they may have. By working together, you can ensure that your electrical installations are safe and compliant. In conclusion, addressing the electrical inspector's concern about using steel staples with aluminum MC cable is crucial for preventing galvanic corrosion. Replacing the steel staples with aluminum or plastic alternatives is a necessary step to ensure the long-term integrity and safety of the electrical installation. Furthermore, understanding the principles of galvanic corrosion and following best practices for material selection, installation, and maintenance are essential for preventing corrosion in all types of electrical systems. By staying informed about electrical codes and standards, and by cooperating with electrical inspectors, you can ensure that your electrical installations are safe, compliant, and reliable. Moreover, remember that electrical work involves potential hazards, and it is important to take precautions to protect yourself and others. Always de-energize circuits before working on them, use insulated tools and equipment, wear appropriate personal protective equipment, and follow safe work practices. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical safety is everyone's responsibility, and by working together, we can prevent electrical accidents and ensure a safe electrical environment for all. Remember to consult the National Electrical Code, or NEC, for detailed requirements and guidance on electrical installations. The NEC is a comprehensive set of standards that covers all aspects of electrical safety, including wiring methods, grounding, overcurrent protection, and equipment installation. It is essential to have a thorough understanding of the NEC to ensure that your electrical work is safe and compliant. In addition to the NEC, there may be other applicable codes and standards, such as local building codes or industry-specific standards. It is important to check with the local authorities to determine the specific requirements for your area. Staying informed about the latest codes and standards is an ongoing process, and it requires continuous learning and professional development. By investing in your knowledge and skills, you can ensure that you are providing the best possible electrical services and protecting the safety of your clients and the public.